appreciate it.
You're welcome.
If you'll get this sheet out, please. Please get this sheet out. We started it on Friday, Thursday. And then on Friday, I left you with the Chapter R exam review packet. You're supposed to work through it as much as you could. Should you know everything on it? Yes. It's from Algebra 2. Have we covered everything on it? No. I think you got towards right here. The rational expressions. So you can only go up to 34, and then 35 through 40 we have not talked about as far as the review goes. And then 41 and 42 it was at the very end of class on Thursday, so which is why we're going to it right now. So you should already have an idea now of what your exam is going to look like. The exam is going to be Thursday. It's going to be, as of right now, in here. I may change my mind. I hate to go somewhere else and test because I prefer to be comfortable in a testing environment, and I don't like fluorescent lights. I don't like being in someone else's room if it's not clean, organized, or stinks. So I don't know where we're going to test yet. We may try it in here. We may see how it goes. It will be on paper. It will resemble the review. And we have two things to look at between now and Wednesday. Wednesday it will be, what questions do you have? What are you still struggling with? Because your exam's tomorrow, right? So that's your format. And then we start chapter 1, which is the material that you're supposed to be learning on Friday. And you will need your Chromebooks by then because that's when the My Math Lab stuff starts, okay, by Friday. Does everyone, Aubrey, do you have your syllabus signed? Okay, I'll get it to you tomorrow. If you have any AirPods in, please take them out. Even if you're not listening to music, it just makes it look better. I did get a pair of noise-canceling AirPods over the summer for my grad class, and then I returned them the next day because I felt like I was in a tunnel. I couldn't stand it. It freaked me out. I couldn't hear my own kids in the background, which is great sometimes, right? But then if one's choking the other one, I wouldn't know it because I had no noise-canceling headphones in. So I thought that was a risk to have as a supervisor of children. So please don't wear them if you don't mind, because then I know you can't hear me. It's fixing to crash. Hold on 1 second. Be kind and be quiet. Be kind and be quiet. I know, the red is hideous.
That's
Right?
basically brown.
That's red. Alright. No. Software does this usually around this time every day. It's great. It's like it's done for the day. Too bad my paycheck doesn't let me be done for the day right now. I had all this filled up. There we go. You do technically, because it's taxpayer money. So it's still go to your wallet. Taxpayer money funds the education. You just don't see money, but you get the education. The services. Well, you'd still have to pay for it if you were at home. All right, look at this organizer. On Thursday we did this one, correct? Pretty sure.
No.
No. Simplifying radicals. This is a square root. You do have a lot of stuff under here. If it bothers you to have a single radical over a bunch of stuff, you could rewrite that in kind of like an a la carte fashion. It doesn't matter. This is me literally breaking it up by each thing. You don't have to do that if you don't want to. You could just work with it from here. You're gonna take the number and break it down by whatever the largest perfect square is that goes into 84, which would be 4 goes how many times? 21 times. So the 84 becomes the square root of 4 times the square root of 21. See that? That's good. What I'm writing? Making a joke? Okay. I got you. I'll get there, I promise. There's so many people, I feel like I can't stand in one place because I either block y'all or I block you. So bear with me. So we got 84 breaks into 4 times 21. Then we've got these variables right here. We are taking the even root, and these are even exponents in this case, which means this should work out nicely, right? It is square root, just an understood 2. So you're saying x to the 4th power split into 2 groups of the same thing would be what? And it would be x squared. Because it divides by 2, right? To take the square root of a variable, you just divide the exponent by 2. That's square root. Now, this is an odd number. Odd numbers are only 1 away from an even number. We did this, I know, at some point on Thursday. You break it apart into the even number and the 1 left. And then I'm going to leave that there, and I'll get it on the next line. But I can see where it's going. That y to the 8th power is fixing to clean up, right? This is the square root of something to the 1st power. You can't do anything with it. So you just leave that. Now you go to the next line and you clean up anything that is perfect. That would be the square root of 4. That's not perfect, so I'm going to come over here and make note. X squared I already dealt with, right? It came out. Is this perfect? Y to the 8th. It's even, so it's, can I take the square root of an even exponent? Yes. 8 divided by 2 is 4, so that comes out as y to the 4th. That y to the 1st power does not do anything, and that z to the 1st power does not do anything. I'm going to write it really big because you can't see that very well. So we have 2x squared, y to the 4th, root 21, y, z. And that would be cleaned up. Yeah. It's ugly. When you are multiplying radicals, you need to know that as long as the root matches, try to draw an arrow there, and then I'm trying to make a note, match, that they have to match. The root has to match. If the root matches, you can just multiply the radicands and write it as a single root. So this is the square root of 15 times the square root of 3, which would be the square root of 45. That we did do on Thursday.
Yes.
Yes, because we broke it into 9 and 5. Yes.
So why do you do square root of y to the 8 to y to the 4?
Oh, because it's an even exponent and you're square rooting it. So y to the 8 for square rooting is like saying the square root of y in expanded form. Square root means what times itself. Y to the 4th times y to the 4th is y to the 8th. So it comes, so it comes out as y to the 4th. So the shortcut is when you have exponents, you just divide the exponent by the root, whatever the root is. It's really important that you hear that. You're dividing the exponent by the root because your homework had some cube roots, which means you don't divide those exponents by 2, you would divide it by 3. So it does matter. It's just we're so used to square roots divided by 2. Those are the more common ones. So this ended up being, just to show how we got here, we ended up with that. getting rid of a radical in the bottom of a fraction. We talked about how there is a rule in math. You cannot divide by 0. Don't go to the beach without your bottoms unless you're in Europe, which is weird. You can't divide by 0. You also cannot leave a radical in the bottom of a fraction. It's a big no-no. We don't have an equation here, right? So we can't like cross-multiply it over to move it. We have what's called an expression. There's a difference. Equation, you see that equal sign, the right and the left. Expression is just that. There's no equation here. So you can't do the whole, whatever I do to the right, I'll do to the left. You can't do that here. The only thing you can do here is multiply by 1. Because nothing changes, right? But the idea is, I can't multiply by 1 and get anywhere. I need to change how the 1 looks so that I can actually get somewhere with this. Enter rationalizing. What is the problem? The problem is the square root of 3. So multiply by the square root of 3 over the square root of 3, because that is a fancy 1, which is why we can do this. And then to multiply, you might be thinking, well, that looks more complicated than what you started with. You just multiply straight across. So this is not under a radical. This is under a radical. They come together like magnets. We have 5 root 3 times root 3 would be 5 root 9. And by design, you've just generated a perfect square, which was the whole point, because now the square root of 9 is, this is actually 5 times 3. So my answer would be 12 root 3 over 15. And then, Billy Mays, but wait, there's more. What happens? The numbers that are not under the radicals actually will reduce, and you are expected to level up to that and be able to recognize, I can keep going. There's a 3 here and here that will divide out. Red means wrong, because all red is wrong.
Yeah.
You can't go in there and divide that 3 out, okay? It's under the radical, so don't do that. Think of MC Hammer, can't touch that, okay? So this is 4 root 3 over 5, and that would be the simplified form. The nice thing about this crap here, you with me? You can type that original expression in your calculator, hit enter, it's an ugly decimal, leave it. You can type your final simplified answer in the calculator, hit enter, they should match. So you know if you did it right. Okay. Same exact concept. What if it's a binomial with radicals? And that is a vocab word called conjugate. Should ring a bell, should look familiar. These are same concept, we're rationalizing. The difference is that is a single term. Terms are separated by plus and minus signs. This is a single term, which means it's very easy. You just multiply by that fancy 1. This is 2 terms, which means if I go in and try to multiply by square root 3, I'm going to end up with square root 21 right here. And that's another issue. I'm just going to have another issue, you know what I mean? So you have to tweak the way the 1 looks. Go back to what we talked about with difference of squares. When you take a difference of squares, x minus 1 times x plus 1. That's a difference of squares. They're almost identical. One difference, the signs. What happens to the middle term? Every time. Every single time it's going to cancel out. The long way to multiply is to say first, outer, inner, last, cancel, cancel. We end up with that. But it's the same pattern. Not 2. Let's do 3. Same pattern. First, outer, inner, last, cancel, cancel. Every time. Every single time. All day, every day. So the shortcut, if you recognize, I hate teaching shortcuts sometimes because some people just run with it every time. And that's not the case. You have to know when to take shortcut, right? The shortcut is when you know it's a difference of squares, when you know it, you recognize it, you're good at that. It's just first and last. Notice it's just the first times the first and the last times the last, because the middle cancels out. Okay, so coming over here and looking at this one right here, I need that to become an expression with no radicals. So I'm going to multiply by the difference of squares, which is called the conjugate. It's actually called the complex conjugate because those are complex numbers. And what you've just done is created a difference of squares along the bottom, which will be pretty when you multiply it out. If it's not pretty, you did something wrong. Either your difference of squares is wrong or your multiplying was wrong. Now, if this is in the bottom, it also has to be in the top. Remember, it's that fancy schmancy one. So what you have now is a monomial times a binomial, and a binomial times a binomial on bottom. And if you want to make a note, this is a difference of squares, which was the point. So to multiply that out, I would have 2 root 3. 2 times negative root 7 would be negative 2 root 7. We just showed you that when you're multiplying a difference of squares, the middle term cancels, so the shortcut is first times first, last times last. So square root 3 times square root 3 is square root 9. Positive root 7 times negative root 7 is negative root 49. Here's a checkpoint. These should be perfect squares. If they're not, something's wrong. So, I'll make a note. Perfect squares. And I'll draw arrows. So that should be perfect and that should be perfect. We don't care about the top. Top's not the problem. It's the rule in math and it has to be going on the bottom.
So, whenever it says square root of 3 plus square root of 7, you have the opposite. Could you not just say, oh, there's 2 3 squared, or yeah, there's 2 square root of 3, then there's 2 square root of 7. So could you just automatically put 3 minus 7 since
Yes, you can.
the square root is
Yes,
go
you
away?
can. If you recognize the pattern when you're generating that perfect square, it does always come right back to that radicand.
I just didn't know if it worked all the
I
time.
get nervous. It does work all the time. I get nervous showing it to some people because then some people will start to use it when we're not necessarily creating those perfect squares. But yes, if you recognize that, it does work every time across the bottom. In both spots, by the way. Like both. Because
Right, that's what I did.
the square root of the perfect is going to come right back to what you just generated it from. So, yeah. So this ends up being 2 root 3 minus 2 root 7. And that's 3 minus 7, which is negative 4. And what do you notice? So you have to be careful here. I hope everybody's watching because this is something I notice people do incorrectly. You need to recognize how many terms you have. So we have terms are separated by plus and minus signs. You also need to recognize what is eligible to simplify. This is a single number, not under a radicand, like a radical sign. That can only simplify into single numbers that are also not under radicals. Can it be attached to one? Yeah, but it can't be under it. You know what I mean? So the only thing you're checking, if you want to get a highlighter and highlight those 3 things, you're checking the coefficients or any single numbers with no radicals. And it's got to come from all 3. It's got to come from all 3. You can't be selective and say, oh, it cancels that one, but not this one. You can't do that. It's got to be all three of them reduced, right? Caden, you with me? Look like you're sleepy. So I would look at this and I'd say to myself, okay, all of those are even, so every one of them can be cut in half, right? So that would be 1 root 3 minus 1 root 7 over negative 2. So I cut them all in half, bless you. So you need to make a note to yourself, divide by 2. Who's asking me this? I would leave it there. It's already ugly. But you can write it in the front if you wanted to.
But wouldn't that make the
But if you're moving it to the top, that's different. So that's why I would leave it in the bottom or put it out front, and it would negate everything correctly. Does that make sense? So if you divide anything by a negative, it's a sign shift, right? So if the negative is bothering you, you can divide the negative, just think of the 1, negative 1. You can divide negative 1 out. This would become negative root 3, positive root 7 over positive 2, which is the same thing. Yeah, if you typed both in your calculator, it's the same decimal. Because that's kind of tedious, you won't see me go that route. I'll be like, oh, this is good.
you have to make sure you make that a plus. Something
You
like
would
that.
have to change everything if you went that route, yeah. Down here at the bottom, adding and subtracting radicals, you've got to recognize when you can and cannot combine them. They have to have the same radicand in order to combine, which means sometimes you have to break them down before you can do any addition or subtraction. For instance, the square root of 27, when you first look at this, you might think, oh, root 27 just comes down. Root 27 breaks down, right, into root 9 and root 3. Let me zoom in. There we go. All right, so root 27 breaks into root 9 and root 3. And the square root of 9 is 3. This comes down. I've done nothing with the front or the back, so now I'm just going to bring those down. Really helps to show your work to root 3. And then now it's just like adding and subtracting polynomials. It's exactly like adding and subtracting polynomials. The radicand has to match. The root has to match. The radicand has to match. They're all square root of 3, so I can combine the coefficients. 8 plus 3 is 11, minus 2 is 9. Bring down the root 3, and that's the simplified answer. If one of the radicands does not match, it would just come down. So like say this had plus square root 5 on the end. Then my answer would have 9 root 3 plus square root 5. And you'd be done. Because you can't combine those. If you look at the next one, you've got the square root of 24 over 12, or plus 12 over the square root of 6. We have a lot going on here. The first thing I'm noticing is 24 has a perfect square factor of 4. So I could break that down. That would be square root of 4 times square root of 6. The square root of 4 is 2. Bring down the square root of 6. I'm going to come back over here and say plus. This fraction has what in the bottom? Got a square root of 6. That's a problem. I can't add those. I mean, you could. You get a decimal in your calculator. But if I'm trying to do the math here without the decimal, we don't want decimals. I need to rationalize this. So what would I multiply by? Square root of 6 over. I'm going to multiply by root 6 over root 6. And I'm just going to do kind of, I call it a side. And you'll see me draw this. I draw like a bracket and I say to myself, okay, I'm going to come over here and work with that, and then I'll plug it back in. So just focusing on this, right? Multiply straight across. I would have 12 root 6 over, that's going to be square root 36, which is 6. Woo, look at this. What happens? This 6 divides nicely into this 12 2 times. Bring down the 6. That fraction is gone. Now I can come down here and replace that mess with 2 root 6. Now you can write 4 root 6 as your answer. So your homework over the, I say long weekend because I didn't see y'all Friday. By the way, congrats on the game Friday. It was awesome. Your homework over the weekend was the 2 practice sheets. One of them was really breaking down radicals, knowing when you can add and subtract, knowing how to rationalize with a conjugate. Let's see. Oh yeah, the screen crashed. Hold on, I gotta pull it back up. I had it up here. So that sheet, I think, is on the back of this graphic organizer, right? Yeah. This one was probably a little easier than the other sheet, because this one, a little, maybe, slightly. This one was checking whether you recognize when sometimes it's undefined, not possible, can't do it, or sometimes when it actually are complete inverse operations and the answer is as simple as the radicand, or sometimes when it's really ugly, but if you just go to your calculator and type it in, it actually ends up being nice, right? Like number 4. Did anybody just try to type it in? Your mind immediately went to clean it up?
Well, I just
When
felt
it's-
like it should be hard.
When it's super ugly like that, check and see if it's coincidentally pretty. So like you go to the calculator, you do have to type the 5 first because it is a 5th root. So you'd hit 5, math, option 5, I think it says x root. And then you would type the fraction and you would see that it's actually very pretty. Just like that scene right there. Let me show you. Alright, so you would type 5, math, option 5. To type a fraction, you can either do numerator, divide, denominator. I personally prefer math print mode because I like to be able to see the fraction so I don't mess up.
Wait, what did you do to do that? Math what?
5, math, and then option 5, and then alpha y equals, was it 32 over 2.43? And it's pretty. It's pretty the whole time. So that one's, there to see, do you recognize when sometimes it's easier just to go to your calculator? Was it 32? And then you would have to arrow down to try to write then you would hit enter, but I'm running out of room. And it's 2/3. What's the square root of 36? Well, when we're just simplifying, it's just 6. If we were solving, we would have to account for the possibility, because it's coming from a quadratic, that there's actually 2 answers. You got +6, -6. Number 2 is saying negate the square root of 36. -6. Negate the square root of 36, which means -6. Number 3 is saying cube root -8. You need to know that you can take odd roots of negative numbers. I'm just going to put a check mark next to it. Like, it is okay to take the odd root of negative numbers. It's okay. Because if you take a negative number and you multiply it by itself 3 times, not times 3, by itself 3 times, you get positive, negative, which means it's okay. You know what I mean? That's imaginary numbers, and we will get to those
Later.
I don't know what chapter off the top of my head. But right now we're dealing with just real numbers. So, for instance, when you get to number 5, you would say not real. And you're not implying it's fake. You're implying the even root of a negative number crosses into imaginary world, and we're just dealing with real numbers for right now. So this would be technically not real. Can you simplify it? Yeah, but it's going to require I. And we haven't reviewed that yet, so right now we're just saying. So the cube root of -8 would be -2. Because -2 times -2 times -2 is -8. So you might want to make a note right here that, and then put like an X, like not good, that you cannot take the even root of negative numbers. It goes into, like he was talking about, imaginary.
So there's no answer.
Not yet. There will be. I said even root. Look at that. I combined my even roots of negative numbers. And I'm going to draw an arrow to say it goes over to imaginary. We're not writing that yet. What is the square root of something squared?
The number that's being
Yeah,
squared.
those are inverse operations, so it's -5. Now you might think, well, now wait a minute, you just said you can't take the even root of a negative. But that negative is being squared, so that's actually the square root of 25, which is 5. So you've got -5 or +5 here.
Both.
Which goes into quadratics. So there's 2 possible answers.
This one is both, or is it negative?
I would accept -5 because those are inverse operations. If you cleaned it up and said it's the square root of 25, you would need to account for the fact that they had written the -5 right there in front of you. You know what I mean? Sure. Well, like number 1. Number 1 was 6.
Yeah.
Because all I see is 36. And I'm not solving. I don't know that I have a quadratic. It's just 6. If I said it's quadratic, you'd say it's positive -6. If you see the negative, then it's coming from the negative. Does that make sense?
So it would be positive.
No. You can account for both, but -5 needs to be whatever. Because the square root of the -5 squared, those inverse operations cancel, so leaving you with that -5. Yes. I would account for the 5 as long as you have the -5 there as well. You would need to say, it's like I was saying to her, like over here with the 36, all I have to go off of is 36. I don't know where it came from. But now this one, this 25, I know where that came from. It came from a negative 5 times a negative 5. So negative 5 needs to be one of my possible simplifications. Number 7, what happens when you cube root something cubed?
It's the same number.
Yeah. Number 8 is the same root. So you can multiply. That's it. And it won't go any further. You can't take the fourth root of 20. 20 won't break down into any perfect fourth power. You can check it if you wanted to, but it won't. Did you get 25 and 2 here? And then, so 5 square root 2 on this one. Ten was, you got 72 over 6. 72 does not divide by 6, does it? Yes, it does. Wait, 12. So this would be the square root of 12. What perfect square goes into 12?
4.
How many times? 3. So that's 2 root 3. Did you get that? You can. You can rationalize. That's the only downfall with going over answers for this topic is there are several questions where there's multiple ways to get there, and we don't have time to go over every answer. Cube root of 8 to the 5th power. First of all, that's ugly. So you could say, let me just check this. 8 to the 5th. And look at that. 32. So this is 32. Another way to recognize that is take the cube root. So 5 will not divide nicely. This is totally like around your head to scratch this here, but you could just do this. So you could say that's the cube root of 8 cubed.
This is what I did.
And you have the cube root of 8 squared. Cube root of 8 cubed cancels. 8 squared is 64. 64 is a perfect cube. What's the cube root of that? 4. 4, which is 32. So 2 totally different ways to get there. I loved if you went this way because you're getting that practice, but honestly you could type it in the calculator. It is pretty. If it's pretty when you type it in the calculator, it's okay to write it. If it's not pretty, then you have to break it down and keep it in radical form. Okay, we need to make progress because we got more to do. So square root of 216. 216 is not a perfect square. Thank you. Oh, it's cubed too, isn't it? 6 cubed is 2. All right. So this ends up being 36. I'm going to break this into 4, 1, and then this into, I ran out of room, y squared and y1. So then I can see, okay, divide the exponent by 2. That's a 6, by the way. It looks like a B. Wow, that really looks terrible. There we go, 36. So this would be x squared. Is it?
Yeah, you'll have a 6 under the row.
Thank you.
Okay.
What's happening?
We're doing math.
I'm just fixing it. So 6 x squared y parentheses radical. It's Monday. 6 y. Huh? You're right. I need to adopt that spirit. I'll get on that. 13. Those are both perfect. Both of them. Don't let the fraction throw you off. They're both perfect. Even root of an even power, and then square root of 4 is 2. This one, you got 4, 2, and then of course you got square root of x squared. That becomes 2, that comes down multiplication, that comes down, that becomes x, right?
Yep.
So 6x square root 2. Split. Repeat. Multiply it out. So that's 4 square root 9 minus 20 square root 6 plus square root 6 minus 5 square root 4.
So we got
4 times 3.
we got 12 minus 20 root 6
I'm going to go ahead and do that.
minus
Minus 10. So,
Yeah, we got. Ooh. I'll be wrong.
right? I had to combine 2 steps and ran out of room. So let me show you where the steps got
There's
combined.
so much happening.
4 times 3, right? Yes. That's 12. Come over here. Negative 5 times 2, negative 10. Come back to the middle. Negative 20 plus 1 is negative 19. Right? Really technical. Plus 1 minus 10.
That was close.
How many do you
Huh?
So once you do like 200
Once you do 200 problems?
Yeah.
I wouldn't assign 200 problems.
Are we gonna go over sugar
Was anyone out Thursday? Y'all don't have these, do you? Pass those back. Was anyone else out Thursday?
What is this?
Oh, it's the real.
It's the review. Which all the solutions are posted.
Are we gonna go over the other homework paper?
Yeah, I need to go to the other thing. Some people were wanting to have more time on that. So I'll pull it up and ask if anyone has questions. But 4 people came to my flesh. They were wanting more time and I'm fine with that. So do another night now that I've gone over the other sheet, which has a couple of things that happened on here. 2, some people wanted more time because now they've got clarification. So I'm going to go over the answers to this tomorrow. So I would like you to try it. I will tell you that some of them, it's exactly what we just practiced. You know, break it down, then combine what will. Some of them, it's recognizing when you have the same root and that you can write it as a singular root, or knowing how to rationalize when it's something other than a square root. So please direct your attention to number 6. Number 6 is the cube root of 5 over the cube root of 4. If you were to rewrite this, don't write this down. If you were to rewrite this, it would be the cube root of 5 over 4. But there's nothing you can do with that, right? Which is the goal here. 7 and 8, I want you to rewrite them as the radical notation based on the fraction. But this particular one, we have a radical in the bottom. So we need to rationalize. comes the problem. What's on the bottom? Root 3 of 4. So if you go back to the notes from earlier, we multiplied by whatever the problem was, right? But we only dealt with square roots. This is cube roots. It's slightly different. When you're dealing with square roots, the goal is to get a perfect square, correct?
Yes.
Okay, we don't want a perfect square here because it's cube root. We want a perfect cube. So whatever the root is, you want that cube or fourth or fifth power. So the idea is I need to multiply by something in order to get the cube root of a nice cubed number. So it all comes from, well, how far away is it from being a nice cubed number? Might help to remember your cubes. 1 squared, cubed. Sorry, 1 cubed, 2 cubed, 3 cubed, 4 cubed, and so on. Which cube can 4 multiply to become? 8. I can get an 8. If I multiply it by what? Cube root of 2. See, remember you can multiply by anything you want as long as the top and the bottom match, because that's your fancy 1. Right? That is a glorified 1 right there. So you multiply straight across, you'd have the cube root of 10 over the cube root of 8. And what is the cube root of 8? It's 2. You're done. Can't go any further. It's now rationalized.
And then you said 6 and 7. You want us to
6 and 7, I just want to see if you know how to rewrite it into radical form. Or 7 and 8. You're rewriting into the radical. Some of these you're just rewriting it. I will say when you get down to 12, I would keep in mind, I'm going to write recall. I don't want to do 12 for you. I want you to try it. I'm going to write x squared over x. Let's do this. Remember this? And we said when the base match, you move it up here and you subtract it. I would do that there. And I'm not asking you to subtract the fractions. You can type it in your calculator. And then you will find it actually ends up being very pretty. And I will tell you the answer is the 4th root of AB. Can you get there? Okay. So we'll check those tomorrow and I'll give you the answers.